So this will be a recording for supposedly activity number 4 for your series of laboratory activities. I will not give this as an activity for you, but instead I will give you this recording in order to demonstrate the transient response of source-free RC circuit. So this is in reference to our lesson 7, which talks about first order circuits, and this circuit in particular is the first question in your assessment number 4 for your lecture class in EE 2165. So this recording is for EE 2166 for your laboratory class. And first off is this source-free RC circuit. And as you can see, as I've already assembled the circuit prior to this recording. So this is highly similar to what we have in our assessment. And in this circuit, we have one voltage source, which is 24 volts, and you can select that voltage source from this drop-down list. So we have DC voltage. We have three resistors, each having a value of 30 ohms, and we have a zero point 0.7 farad capacitor from which you can adjust the value of capacitance here or in this pane. Then we also have a switch so that we can turn on and turn off the circuit while running the simulation. And you can select the switch from this drop-down list, and it is called a single pole single throw switch, or SPST. So what I want to illustrate in this simulation is how the voltage across the capacitor is varying through time. So as the circuit simulates or is running, um, the value of the voltage across this capacitor C1 also changes. And right now, the capacitor is not yet charged because that switch is still open and we haven't run the simulation yet. So the value of 3.6 microfarad is actually negligible and is very close to, when you solve it, 0 volts. So I've assembled this circuit, and just a reminder that when you run a simulation using multisim, you need to connect a ground for the entire circuit. Otherwise, the circuit will not work. So let's do this. So once I press play, so you would have an indication that the circuit is already up and running once the time has already started running. So we have 7, 8, then 9, then 10 seconds, 1 second. So I've reduced the amount of time in order to properly illustrate how the voltage really changes. So right now the capacitor is still not yet charged, but if we turn on the switch, then that's the time when the capacitor has started accumulating charge. So since capacitor stores energy, then it stores energy slowly. So I want you to notice the behavior of the capacitor's voltage. It increases slowly and steadily. So let us see at which value does the capacitor peak its voltage or its stored charge. So still at this time the capacitor is storing charge. Now it climbs up to 4 volts. I think it will flat out at a value of 8 volts. I'm not really sure, but let's find out. So while the voltage is still changing, or at this case still climbing up, we would like to call it as our transient response or the temporary response because the value of the voltage is still changing with respect to time. And you can see that because we have a voltmeter connected here, and it gives us a virtually real-time measurement of the voltage. Fast forward, it's already 88 seconds from our simulation and our voltage has already climbed to 8 volts. It's been really slow for the voltage in the across the capacitor to climb up to 8 volts. So I think that's the cap for the voltage that for the voltage maximum voltage rather that the capacitor can charge. So right at this moment we will disconnect the switch and let's see how the voltage across the capacitor responds while the simulation is still up and running. Wait. So right at that moment the switch has already been opened and the voltage across our capacitor has uh, has been reduced and is continually going down. So when the switch is open, the we will expect that the voltage across our capacitor will reduce down to virtually zero, but it's taking its time to, discharge all the stored charge. At this moment, it's been very a few seconds has already passed, and we will expect the voltage to continue to lower down to almost zero. Again, almost zero. So what happens to the stored charge is that it gets dissipated to the nearby resistors, since when the switch is opened, these two resistors are the only components which are directly connected to our capacitor, and thus they absorb and dissipate the energy stored from the capacitors. So that is just to illustrate you how a transient response looks like for a capacitor. So it increases and decreases voltage when the voltage source uh, is connected and disconnected. So that's it. Paul will be the second question in your assessment number 4, and this is the RC circuit with source. So again, I've assembled the circuit already and it is ready for simulation. But before that, the switch that we are using here is a single pole double throw switch SPDT. So this is characterized by having two um, throws for a switch. So the voltmeter is already connected. in our capacitor, which is valued at 0.7 millifarad. So this is slightly smaller than our previous example, and hopefully the time that it will take will not be as long, will not be just as long as the first example. So let's run the simulation, and we can see right away that the voltage, when it is in position A, or in when the switch is in this position, the value across our capacitor, the value of voltage across our capacitor is 15 volts. So that's our the first part of the simulation. But if we are gonna switch this this capacitor to the other source, let's see what would happen. So the voltage is now increasing in value. So from 15 volts it climbs up, and we would expect this behavior since the voltage source that is in connection to our capacitor in this position, when the switch is in this position, is higher than the other voltage source. So between 30 volts and 40 volts as a voltage source, we would expect that the voltage across the capacitor would be higher with the 40 volt source. So hence, the voltage across our capacitor still continues to climb up. And this is generally the transient response of our circuit for an RC circuit, in particular with a source. So it doesn't reduce to zero levels because of the presence of the voltage sources for both sides of the switch. The voltage across our capacitor has already capped at, let's say, 40 volts. And it makes sense because the voltage source connected to our capacitor is for 40 volts. So right now, let's begin to switch the connect the capacitor to its original position before. So let's click the switch, and we can see immediately that the voltage across the capacitor immediately reduces, and we would expect that to go back to 15 volts where the voltage has started. So that is again the transient response for our RC circuit with source. It will not reduce to 0 volts, and we would expect that the energy in the capacitor is not dissipated in the resistors because in each side of the circuit there are voltage sources. So again, we would expect the voltage in our capacitor to reduce back to 15 volts. So that's it. So this particular example is the third item in your fourth assessment, and this circuit is an RL circuit with a source. So in this simulation, let us see how a current through the inductor would behave under a source, and what the transient response will look like for an inductor. So again, I've assembled the circuit. We have our inductor here above. We have two resistors valued at 30 ohms. Our inductor is valued at 3 henries. We have a current source at 6 amperes. And of course, we should not forget our ground node, our ground connection. So I've placed the ammeter here beside the inductor, and this will give us a virtual real-time reading of the current through our inductor. So If we are gonna run the simulation, we can see that our inductor has a current of 3 amperes. In fact, negative 3 amperes because of the opposite direction of our ammeter. But if we are gonna connect or close the switch, then our current will steadily increase. So that is our transient response. The change in current through time is the characteristics of our transient response for an RL circuit with a source. So our current now is 6 amperes, which makes sense because at the steady state, our inductor will act as a short circuit and will virtually this branch will carry the entire current from the current source, which is 6 amperes. So that's our steady state current, and that's where our current will flat out. But if we're gonna open the switch again, this current will reduce back to 3 ohms. And we started with 3 amperes rather. And we started with 3 amperes because for an RL circuit with source, we will not start at 0 because of the presence of the source. So just to illustrate you how quick the transient response for our RL circuit with source is. So this video is relatively short, and let me stop the simulation right there. You can try it out for yourselves. Um, this simulation, this multisim doesn't give you the equation, but rather it gives you a real value taking into account the time. So again, the assessment number four, for assessment number four, I will not give this to you as an activity for laboratory, but instead this recording of our simulation will act as our learning material for activity for assessment number four or our lesson number 7. So if you have any questions, please don't forget to, inform me, send me an email, give me a quick chat, or leave a comment in our Google Classroom. And again, stay safe. And for the first 3 activities, I've already uploaded this on the Google Classroom. I hope that you've been notified, and the deadline for these 3 activities is on October 19. So that will give us ample amount of time to do the simulations. And these simulations, by the way, are very quick. They are really easy to do. You just have to assemble it, and it will not take you a long amount of time to, you know, make the simulation. So I hope that is not too overwhelming for everyone. So again, thank you so much and stay safe.